I'm just going to set up my special bridge here. I can assure you that a number of jelly babies were harmed in the production of this bit of kit. My structures that I actually design are a little bit more stable than this. I'm going to show you as well. There you go. Well, thanks very much for coming. As Helen mentioned, my name is Roma Agrawal. I'm a structural engineer. I worked on the Shard for 6 years, but today I am not going to talk about the Shard. I'm sorry about that. I've spoken about it 45 times in the last 2 years, so I want to talk about bridges instead. I hope you will forgive me. So, that was me. Thank you. Obviously, the engineer, I was wearing my dad's suit, and he was an engineer, and I was making some kind of helicopter, which I don't really think looks like it had any capability of flying, but there you go. And it might seem obvious from that photograph that I wanted to be an engineer my whole life, and this was my big calling. But no, I had no idea what I wanted to do with myself. But I loved maths and science, and I was, I guess one of the lucky few that was really encouraged on this journey of science. And I realized that actually I loved making stuff, and I loved maths and science, and I thought, well, what can I do with that? And it took me a long time to work out that engineering is the answer, but I'm really glad that I managed to make that journey. So I am a structural engineer. So how many of you have any sort of clue what structural engineers do, or have met one, or have an idea of one, what they might look like? Just a whoop, a show of hands. And yeah, I've got a few. So my job is to make sure that buildings and bridges stand up. So, there's not a lot of responsibility there or anything. I worked on the Shard, as I mentioned, so that's the tallest building in Western Europe. I worked on the foundations of that building, so this is never going to happen, but if it does sink, please forget you ever met me. I also designed the very top of the tower, which is where the viewing gallery is. So if you do go up into the viewing gallery, forget the views, it's London, you've all been there. Look up at the steel, much more interesting. On the other side of the screen, you have Hereward at Covent Garden, which is the tallest sculpture in Covent Garden. I have no idea if that's true. But I put that project up there just to show you a bit of a range of the types of things structural engineers do, because we might forget that actually big sculptures like that can tip over and knock someone on the head, so a structural engineer needs to come in and make sure that that doesn't happen. So the middle bridge there is bridge number 1 for tonight. It is the Northumbria University Bridge, aka my baby. It's the first project I ever worked on. I was 22 years old, came into the office, and my boss gave me the sketch and said, we need to put this bridge together. So the students had a wonderful sort of old historical bit of campus there. They've got a new massive campus here. No way of getting across the motorway, the train tracks. Put a bridge in. Good idea. So we had a number of different constraints to work with. We had to make sure that this deck wasn't so deep so that the cars couldn't pass under it. Same on this side where the trains went through. We wanted to reuse existing walls on one side of the bridge, so we wanted to make it nice and light. So we came up with this scheme. This is a sketch that my boss did many years ago. And we had to come up with lots of different ideas. So we had constraints, we had challenges, we had a bit of creativity coming in about how we can best basically get the students from one side of the campus to the other. So that was the big picture. People sometimes ask me what my favorite bit of the bridge is. And if we take a look at the very top little bit up there, that's this bit here. And again, constraints. So I've got tension in these cables and tension in those cables. They're all coming together at a point. I need to make sure that the steel doesn't yield, it doesn't bend, this pylon doesn't fall over. So maths and physics come up with a few different ideas and decide how to put it together. We also need to think about how it's going to be built. So, fine, I've got this wonderful looking bridge, but if you can't actually build it, then what's the point? Now, I have a slight obsession with cranes. I look like the type, don't I? And some sketches there again to see, where can we put the cranes, and how long do they need to be there, and how much are we going to disrupt people's lives, and so on. So, my point with this example is we get, challenges as problems, creativity, ideas, pick the best solution that works for everybody. And that's really, I think, the essence of engineering. So there's a couple of photographs there of a real crane lifting in my footbridge, and the very top of the footbridge as well, which is the sketch I showed you. And honestly, it honestly fills my heart with joy when I see my little sketches turn into something real that's going to hold a footbridge up. And that is the bridge. And I'm very pleased to say it's been there for 8 years and it's still standing. So bridge number 2 is the Brooklyn Bridge. So I'm going to take a step back in time. Now, the kids this afternoon thought, oh, did she work on that? I have a fantastic plastic surgeon. So Brooklyn Bridge is a very, very special bridge, one that I enjoy looking at, and it's Emily Roebling's baby. And I'll tell you a few facts about the Brooklyn Bridge. It was the longest bridge of its time. This was in the 1880s. It was the first bridge to use steel as its primary material instead of iron or concrete. And they also used this revolutionary method called, or kit called caissons, which they basically lowered into the water. They pumped all the water and the mud out, put air in it, and then some poor sod had to go into that and then break out the ground and the rock to put the foundations in. But there's lots of amazing things going on. It was designed by an engineer called John Roebling and his son, Washington Roebling. They were both engineers. They designed this bridge. They did lots and lots of work on it. Construction starts on site. Tragedy hits. So John Roebling has an accident on site and dies. And then about a year later, less than a year later, his son has an accident on site and is paralyzed. And now no longer can this family fulfill their obligations to get this bridge built. Enter Emily Roebling, Washington's wife. And she says, well, I know a little bit about maths and science. She started to take lots and lots of notes from her husband and basically become a messenger and pass these messages on to the builders on site to try and get this built, and basically tried very hard that the family shouldn't lose the project. But over the course of 11 years, she studied mathematics, engineering, complex cable theory. She learnt it all. It was no longer that she was a messenger. She was the chief engineer of this project. But the thing I really admire her for is that she wasn't just great at the technical skills. In the 1800s, when men thought that women's brains were not capable of understanding engineering, she convinced all the politicians that she was the right person for the job. She convinced the builders on site that she knew what she was doing. And I'm going to stop the story there because I've written a chapter on this lady, this wonderful lady, in the Ada Lovelace Day book, which comes out next year. So please buy a copy so you can find out what the end of the story was. But I could give you a clue. It was a fantastic end to the story. So bridge number 3 is the Jelly Baby Bridge. I don't advise anyone wants to eat any of these because about 400 5-year-olds have touched them. So unless you have a gut of steel, I would stay away from it. So resonance. Do we know what resonance is? Show of hands, yeah? So I don't need to explain this in terms of how a swing works and things. But the Jelly Baby Bridge is basically a way to show some different modes of resonance that you might get in a bridge. So the Wobbly Bridge in London, the Millennium Bridge, had people kind of walking on it, and it excited a sideways mode. So what was happening is when you walk, you're putting some force into whatever you're walking on, forwards and sideways. And it just so happened that the sideways frequency matched the frequency of the bridge, and it started to wobble. You can also get bridges where it wants to do a sort of vertical thing, and the bridge feels a bit bouncy, and I'm sure we've all felt that when we walk on a bridge and it feels a little bit bouncy. But what I wanted to look at today was really the kind of the twisting mode. And this Jelly Baby bridge is great to show you this wonderful sort of wave motion that you can get in a bridge that we call the torsional mode of resonance. And my Jelly Baby bridge is quite flexible. It's made of duct tape. If it collapses, it's not going to kill anyone. And then, of course, there is this amazing footage from the Tacoma Narrows Bridge. And you can see there, I don't know if any of you have seen this footage before, it's absolutely unbelievable. But you can see it is literally doing what my Jelly Baby bridge is doing, except that it's wind that is causing this effect on this bridge. Absolutely unbelievable. So this bridge is from the 1940s in the US. Now, that bridge is obviously not going to be as flexible as mine, so total collapse follows. And I bet the structural engineer that designed that bridge was not very happy when that happened. And I'm pleased to say that no people died. The man that took this video was in his car. He kind of rushed off and happened to have a video camera. But unfortunately, his dog did go down in that car. But when that doesn't happen, and when the structures that you design stand up and are there for your grandchildren and their children to see, it honestly is the most rewarding thing to design things and actually see people using them. So just my little summary. Engineering is maths and science. Of course, you have to understand it and you need to enjoy it. But it's also about creativity. I showed you the different sorts of problems that you might experience in designing a bridge. You have to be creative in order to solve those problems. I talked a bit about people. I can't just sit behind my computer and hide and, kind of do my computer thing all day. I have to talk to people like Emily Roebling did and convince them that you're the right person for the job and basically bring people together to put together a building, which is actually quite a complicated thing to do. And I've also talked about how rewarding a career in engineering is, because there is no feeling like walking around London, seeing the Shard pop up and saying, I helped design that. Thank you very much.
Don Norman was one of the first people to talk about use and about designing for being usable, and also, in particular, designing for pleasurable use or non-pleasurable use, just emotional reaction to things.